are going to be looking at some few revision tips for maths, grade 11, and we want to quickly look at how to deal with your Euclidean. Right. Now, when it comes to your Euclidean, it is a must that you must know how to prove. It is a must to know the proofs. Please, it's a must that you know the proofs of the theorem. It's in your textbook. You can just learn or write it as many times as possible. We are going to focus on application of those theorems. And I'm going to run through in a few minutes what some of those theorems are. And I will be using the acronym, the doctors in Cape Town. The doctors in Cape Town. Alright, the doctors in Cape Town. When we say the doctors in Cape Town, number one, I'm looking at a diameter. If I talk about a diameter, then I should be looking at angle at the center. Alright? So if I have there a diameter, alright, so we should be looking at angle at the center. So if I have that, I can then draw. Once you have that and you are told that this line here is a diameter, we must start thinking immediately. Okay. What you need to start thinking about immediately is that there should somewhere along the line there would be that. Somewhere along the line there will be that. And once you see that, what's coming to your mind? Angle in a semicircle. So once you see the word diameter, start thinking about this. In most cases, this is hidden somewhere. Alright, diameter. Okay, let's go for the next one. Radius. So doctors. So we have a radius. Alright, so if you were to have that, what are the things that should come to mind when you have a radius? Okay, I'm going to use that as my center. You have that. Now, the thing that should come to mind, immediately you can identify the word radius, or if you don't see the word radius, look at diagram. If you see a radius, is that you are thinking about angle at the center is twice angle at the circumference. Now, that's an automatic thought pattern that you should have. Alright? Okay, angle at the center is twice angle at the circumference. Alright, angle at the center is twice angle at the circumference. So, you see, these are automatic thought patterns that we must have. Alright, automatic thought patterns that we must have. Alright, that's not all. Again, let me use a different color this time around. What are you thinking about again? Think about that. Now, what do you know there? Angles opposite what? Equal sides. This angle here is equal to that angle there. Why? Because these radii. So you are thinking about angles opposite equal what? Sides. So here, what are we thinking about? We're thinking about angles in what? A semicircle. Here you're thinking about angle at the center, alright? Angle at center equals to what? 2 times angle at circumference. Now you're also thinking about angles opposite what? Equal sides. Now, these are things that you must just quickly think about. Alright, it may not be there, but in most cases you should find this there. Now, S, same segment. Same segment. Okay. Same same segment. Alright, so if I have same segment, what if I want, once you can identify same segment, then you are thinking of your butterfly principle. Alright, same segment. What do you know immediately? Immediately you see that. You're thinking about that is equal to that angle there. Alright? And there are different variations to this. A lot of different variations. Okay? I could then have this. Just going to draw small circles. Alright, I could have this. Since we're talking about variations of that same principle there. Alright, variations of the same principle. Alright. So what the examiner is trying to show us here is then you find your symbol of equality. Automatically it means this angle here is equal to that angle. We're just looking at variations. Another variation could be like this. Alright, with my center. What does that quickly tell us again? That tells us that this angle here is automatically equal to that angle. Alright, so we're looking at angles in the same segment or angle subtended by equal chords. Alright, so the word S, same segment, same chord. Right, so it could be in different variations there. So these are the things you're looking for when you see those equal signs in your circles. Alright, so that is ductus. The next one, C, cyclic chord. Alright, here there are three theorems or three things that we should be looking at. Number one is to understand what a cyclic chord is. Alright, so if I have the four edges, it's a quadrilateral. If I have the four edges touching the circle, alright, then I am talking about a cyclic chord. And once you talk about a cyclic chord, what we would then look at is this. Number one, this angle here is equal to that angle there. And we talk about what? Exterior angle of what? A cyclic chord. Exterior angle of a cyclic chord. Exterior angle of a cyclic chord. Alright. And that leads us to another section here, because that's a straight line, 180 minus x. And because it's a straight line, automatically we can then add these two angles together to give us what? 180. So we said opposite what? Angles of a cyclic chord are supplementary. Alright, and finally on a cyclic chord, so it's 1, 2, those are the things you're looking for, especially when they ask you to prove a cyclic chord. Alright, let me use a different color there. you have that again. Once you have that same segment section again there, that tells you it's a cyclic chord. Alright, so you have that in a cyclic chord. This angle here is also equal to that angle, which takes us back to the same segment stuff there. That's another way of proving a cyclic chord. Alright, so angles in same what? Segment. Once you find it in a quadrilateral shape within a circle, we'll talk about cyclic chord. Alright, doctors in Cape Town. Next letter represents parallel lines. And once you talk about parallel lines, it's just a few things that you're looking at here. You're looking at your fan. Alright, you're looking at fan. Okay, let's try to get fan. We're looking at fan. Alright, capital letter F. Okay, we're looking at F there. Alright, F. Okay, I want a U that alright, but okay, so we're looking at fan there. Alright, although this U is not giving me the type of U that I want. Okay, let's check something here quickly. We might be lucky to get I doubt that we would get a U that I want, but we would use it in anyway to explain what we want to do. And I'm sure you know what we are about to do using that. Alright, apparently we're not winning, and because of time, fun. Okay, basically when we look at that, we are trying to remember that that's possible because that line is parallel to that line. And this one, okay, I'm going to try as much as possible to create my own. Alright, so that's fun. Alright, now if we look at that, we're trying to create our own parallel lines. So this line here being parallel to that line, and this line also being parallel to that line. Now what are the angles we're looking at here? We're looking at this angle here equal to that angle, and we talk about what? Corresponding. Alright, we're looking at this angle and the angle here as co-interior, and we know that they are what? Supplementary. And then finally we're looking at this and this, and we call them what? Alternate angles. So, and that can only happen when we have our parallel what? Parallel lines. Okay, now that's it in Cape Town. Now town means your tangent. Alright, tangent. Now so we have our circle there, and then we have a straight line. Please remember that your tangent will not go through the circle. Your tangent will not go through the circle. Alright, so here we're going to be talking about three theorems as well. Let's have that. Okay, we have that, and I'm then going to try as much as possible to get myself another tangent that will, yes, okay. So you see, we can actually create our own Euclidean questions here. Now let's start looking at the chord. Number one, this is a tangent. Okay, let's call this A, B, C. If you look at this, tangent, let's call this a D. All right. There is a chord here that forms an angle. Look at chord BC and the tangent CD. There is an angle somewhere here between the tangent and the chord. Now then we trace chord BC and see which angle BC forms. BCB actually forms an angle, or they meet at angle A. It means this angle here is equal to that angle, and that's your tan chord. Alright, that is your tan chord. Alright, I want to do something here quickly and put another line here. Okay, and let's call this F. Alright, yeah, it's getting complicated now. You would notice that, look at my tan here, my tangent, makes an angle with a chord called FC. Alright, look at this tangent, and I'm drawing it up to a chord, that angle there. What is that angle going to be equal to? Which chord are we looking at? Chord FC. Alright, notice what happens. Chord FC meets at angle A, but a bigger A. Alright, so if this is X, this will have been X. So if this was Y, that will have been what? Y. So that's tan chord. Alright, that's so beautiful. And already with what we've said earlier on, it means this angle here is equal to that angle where I have the dots. Angles in the same segment. And because that is so, it means that ACFB or ACBF is a cyclic chord. Alright, you see, merging all of these things in one piece. And we also must know that FG therefore should be equal to what? DC. Alright, tangents drawn from the same point are equal. Tangents drawn from the same point are equal. So basically, if you go back to where we started from, and that's what we doing this video for doctors in Cape Town. So if you have your diameter, you have angles in a semicircle which is 90 degrees. When you have your radius, we're talking about angle at the center is twice angle at the circumference. Angle at the center, twice angle at the circumference. Angles opposite equal sides, right? And the equal sides being radii. S, same segment or same chord. Right, we drew a bit of this. Angles in the same segment are equal. Angles of the same chord are also what? Equal. Cyclic chord, we said there are three things. Exterior angles of a cyclic chord, opposite angles of a cyclic chord are supplementary, and angles in the same what? Segment. Then we look at our parallel lines, we talk about fan, we talk about corresponding, co-interior, alternate, and then we talk about our T, which is our tangent, and we talk about our tan chord and equidistant chord. So we talk about our tan chord and equidistant chord. Alright, so we talk about our tan chord, and then we talk about equidistant chords. Chords drawn from the same point are equal. Alright, now so if you get all of this, the only one that I'll just quickly go over that is not here would be this. If I have that and I have a center there, and we have that, we could have actually talked about that when we talked about, okay, now let's go back so that we have it all there when we talked about the radius thing. Alright, we can actually take it from the radius thing. Alright, that the angle drawn from the center, alright, which is theorem 1. Okay, theorem 1. So let's put that here as well, that angle drawn from the center perpendicular to a chord will do what? Bisect the chord. So that can just go in there. That angle drawn from the center perpendicular to the chord will do what? Will bisect the chord there. Alright. So having said all of that, we have all our theorems just in one piece. Alright, all our theorems in one piece. Then that is equal to that if this is 90 degrees. We have our theorems in one piece. Alright, line drawn from center. Perpendicular to the chord. We'll do what? Bisect. Okay, so we have all of that. Let's try a few questions. See if we can apply all of this. Okay. All right. I know some of you've got these questions. Doesn't matter. We just want to go through a few principles. All right. Look at this diagram. Look, without even talking much. If I were to annotate on this, all right, check. The first thing that catches my eyes quickly is that O is the center as given in the statement. All right. Automatically, you know what that tells me? That tells me that I should be looking at radius. Because if I look at doctors in Cape Town, let's check. Since there's no diameter, but there's radius, R. So I'm looking at angle at the center is twice angle at the circumference. Do you think we have that there? Yes. Angle at the center there is twice. So if this is 39, this becomes what? 78. Alright, see, radius. What about same segment? Okay, I'm looking at this sign, and I'm looking at that sign. It means the angles are equal because AB, same chord, AB is equal to what? DC. Remember, same segment, same chord. It means it is what? 78. Alright, without much ado, it means I can get this angle here. Opposite, angles opposite equal sides, which will be what? 180 minus 78. Alright, because these angles are equal, and we divide that by what? By 2. This angle therefore is 51. This angle therefore is 51. Which also makes this angle what? 51. And that angle becomes what? 51. Alright. Look, I think we've gotten all the angles that we can get in this diagram. And it just makes life very simple for us. Let's see what the examiner really wants. Size of O1. We got that angle at the center. Size of O2, we got that as well. Done. Alright. Oh, here we have another one. Alright, we have another one. In the diagram, S is the center of the circle, PQ, RT, PT is a diameter. Alright, I'm looking at that word. PT is a diameter. What comes to my mind quickly is that. Does that exist here? Unfortunately not. Please don't make a mistake to say this is 90. It is not. For that to be 90, then this must come that way. Unfortunately, we do not have that coming our way, so we don't have that as 90 degrees. Alright, then let's check. Let's read through. Okay, so this is not there. Alright, RST is x minus 8 and PQR is 2x minus 40. Oh, it says determine the value of x. Alright, okay, I see there could be varieties of ways to do this. And if we then look at the varieties of ways that we have, we can actually use angle at the center is twice angle at the circumference. The question is, which chord are we going to be using? Angle at the center and angle at the circumference. However, that might not be very visible for everyone to see. What I can then do, okay, let's do this. What if we join this? You are allowed to do that. You are allowed to construct. Then I have a cyclic chord. Alright? Then I have what? A cyclic chord. And, wait, check this. Do you see R there? Yes. And when we talked about R, that's a radius. That's a radius. Because we are told that PT is a diameter. Aha, makes sense. Now when I look at R, I'm looking at what? Angle at the center is twice angle at the circumference, or I'm saying your isosceles triangle, right? Angles opposite what? Equal sides. Which means, I don't know if you've seen the solution here. I can then get my angle T, alright, by saying, since T equals to R, angles opposite what? Equal sides. Then I have 180 minus x minus 8. Remember, you have to put that in bracket. Alright, divided by what? By 2. Okay, we can break this down to say this is 180 minus x plus what? 8 divided by 2. What is 180 plus 8? That will give us 188 minus x divided by 2. This is angle T. We divided by 2 because these angles are equal. But then I look at PQRT as a cyclic chord, and I know that this angle plus this angle here, which is angle Q plus T, should be equal to what? 180. Reason? Opposite angles of what? A cyclic chord. Alright, opposite angles of a cyclic chord. Okay, I don't have space. Opposite angles of a cyclic chord. Therefore, mathematically, can we then say that 2x minus 40 plus 188 minus x over 2 should be equal to 180, because we said they are supplementary. Let's go check that algebra. Let's go check that algebra quickly. Alright. Let's check that algebra and work it out. X minus 40 plus 188 minus x. Now this is all algebra. I think for me, I will just multiply through by 2. So what do I have? 4x minus 80 plus 188 minus x equals to what? 360. Now 4x minus x would give me 3x. And then I have all my numbers on the other side, which gives me 360 plus 80, because we take it over that side, minus 188. And that gives us 252. And we need to divide that by 3, which gives us x as 84 degrees. Alright, and I believe that works perfectly for us. Alright, now if we look at the next question here, let's say this. O is the center of the circle, alright, and chord 8. So we use here, we're basically using theorem 1. AC is equal to 8x, alright, and OB is 2x, so that is 2x, and AC, the whole of AC is 8x. Can I say that this angle is, this line is equal to that line? Angle drawn, line drawn from the center, alright, perpendicular to the chord will bisect the chord, so that is 4x, and that is 4x. Alright, now, you see, examiners, this examiner is actually nice by completing this OA and OC for us. In most cases, they don't. Alright, now once you see all of this in 90 degrees, you're thinking about a Pythagoras. I can therefore calculate OA using Pythagoras. So can I say OA squared therefore equals to what? AB squared plus OB squared. And that will be equal to 4x all squared plus 2x all squared. Okay, let's see if we're going to get an answer here. 4 times 4 will give me 16. Alright, so I do have what? 16x squared plus 4x squared, which actually gives me 20x squared. Right. Remember, we're using Pythagoras. OA squared equals to AB squared plus OA squared. And you have to state the reason for making this 4x. Alright, which is theorem 1. We did that. But now that is OA squared, which is basically, but OA is equal to OD, radii. Therefore, OD is actually the square root of 20x squared. But what are we looking for? BD. What do you notice in this line here? That OB plus BD should be equal to what? OD. What is my OB? 2x. Plus, what is our BD? We don't know. But what is OD? Alright. We can then break this down to say BD will be equal to root of 20x squared minus what? 2x. Okay. What is the square root of 20? You have your 5 times 4, which is 2 root 5. Alright, so I have 2 root 5. And what's the square root of x squared? That is x, right? Minus 2x. Can we then bring out what's common? 2x is common. What do we have left? Root 5 minus 1. And that's what we are looking for. Lovely. Alright, so that requires your calculation and your Pythagoras. So anytime you think about that, please think of a Pythagoras theorem because of the word perpendicular forms a right angle triangle. Alright, and the diagram below, O is the center of the circle and PTR is the cyclic chord. I'm sure we're trying to prove something here. Oh, there's no question there. Okay, there's no question, but I guess it's a proof. Alright, okay, let's look at this one then. In the figure, QS and PR are diameters. Okay, let's keep the word diameters. Alright, let's keep the word diameters. We know what you're thinking about right now. Center O such that PQ are parallel. Fine, it's going to be fun. It's really going to be fun, yeah. Alright, PS is produced to T, N is a point on the circle. Please, you need to keep your eyes on the diagram as well. Once you start seeing all of that, alright, N is a point on the circle such that Q1, angle Q1 is equal to angle Q2, and SN is drawn. RN intersects N, and we have a 48 there, alright. Please note, quickly, I know some of you are tempted to say you've seen a tangent here. There is no tangent. This is not a tangent, alright. It is not, because it passes through the circle. So please, that's one mistake that learners will quickly make and say is a tangent. I'm not even going to look at the questions. I want us to see what we can get from here first without us looking at the question. Without us looking at the question. Alright. We want to work by inspection. QP, alright, QP SN. It's a cyclic chord. Alright, the 4 edges are touching the circle there. Okay? Which means the whole of angle, this angle here, must be equal to angle 48. Exterior angles of a cyclic chord. In case you don't see that, I'm going to use something here. Look at this. Okay, let's look at this. It's a straight line. What does that tell you? It means this angle here is 180 minus 48, right? 180 minus 48. And since we know that 180 minus 48, and we know that angle Q and angle S are supplementary because of the cyclic chord. 180, so this is going to be 180 minus the whole of that. Automatically, this gives us what? 48. That makes this to be 48. However, I remember that we were told that Q1 is equal to Q2. If Q1 is equal to Q2, what does that tell us? This angle is 24 and this angle is 24. Alright, so take note that 48 is the whole of Q1, but we are able to break that down. All right. Now, do you see parallel lines? What is 180 minus 48? Let's have an answer there. 180 minus 48 would be equal to 132. All right, 132. I'm just going to clean this quickly. 132. So this whole angle here is 132. All right, but do you see my fan? All right, this is an F. I want us to see. I'm going to use this. It's an F that is on the opposite side of inverted F, which means this angle here is equal to that angle there, because these two lines are parallel. By the way, not 48, it is 48 plus 2. Is that okay? 48 plus 2. So please be careful about the angle you make to the 48. Alright, now we have that. So we know that this is going to be angle S1 plus S2. Alright, having said that, what other angle can we find? What other angle can we find? Oh, by the way, we know that O is the center because we're talking about a diameter. Well, we should have actually written that down, but forgot. Doctors in Cape Town. Alright, so if I have that, we're given that this angle here at this line PR is a diameter. Do you notice it subtends an angle here which is 90 degrees? I hope you're getting that. So S3 plus S4 equals to what? 90 degrees. Angle in a semicircle. Now, do you notice I've got my S1 plus S2 plus S3 plus S4 to be equal to what? 180. S1, 48. S2, unknown. S3 plus S4, 90. Which means I can get my S2 by simply using my mathematics here to say 180 minus 48 minus 90, and that gives me 42. So this angle here now is 42, which allows me to get my angle P, 42 plus 48, alright, and that would give me what? 90. Alright, this angle here, oh, by the way, I didn't really even need to calculate that. Alright, 90, because QS is also a diameter. Alright, you see QS is a diameter. That gives me my 90. This is actually very, very beautiful here. Alright, now, if I see that, look at my QO, it's a radius. My QP, another radius. That tells that this is equal to that. So if this angle is 24, that makes this angle to be what? 24. Angles opposite what? Equal sides. Therefore, I can get that angle by saying that 180 minus 48, and that gives me what? 132. Which also makes this angle to be 132 vertically. Opposite what? Angles. And this makes this angle, look, we're getting all the angles we can get. That's angle on a straight line, right? And that gives me 180 minus 30, which gives me 48. This gives me 48. And vertically opposite, 48. I don't know if there's an angle that we've not actually gotten, but I can, oh, it's messed up, but I hope you are following. Let me try to change something here and use that. Since I'm dealing with parallel lines, can I create a fun thing? I want an N. Alright? If you check this, that line is parallel, then I have that line in between the two parallel lines, N. So if that is 24, this angle is also what? 24. And what's the reason? Alternate what? Angles. Alright. The same thing here. This and that and that. So if this is 24, this angle is also what? 24. And since I know that this whole angle here is 90, and I know part of it as 24, 90 minus 24 would give me 66. it means this angle is 66. And I want us to prove it. This line here is equal to that line. It means this angle should be what? 66. But we know the whole of this as 90, remember? 90. 90 minus this small part, 24, will give us what? 66. Alright. Okay. Finally, I think we're looking for angle N. And angle N we can simply get by using a cyclic chord QP. No, we don't even need it. QS is a diameter. This angle is what? 90 degrees. Because 90 plus this 90 here would give us what? 180 degrees. Alright. And this angle here, okay, is 90. Good. All said and done. Let's check what this examiner really wants. I think we've overworked. Q1. Okay, Q1 is 24. We got that. You need to rewind this video so you'll be able to write down all the reasons. Alright. Be able to rewind and write down all the reasons. Q1 we got to be 24. Did we get R? 24 alternate angles. Alright, so Q1. M1. Alright, we didn't get M1. Oh, but we can get M1 now. Let's see, we can get M1 since we have a triangle. Do you see a triangle there? Alright, since we have a triangle there, so this is 180 minus 90 minus 42. Alright, so 180 minus 90, or just say minus 42 there, alright, which is 66. Alright, we can talk about angles in 48. Alright, 48, 90 minus 42 would give us what? 48. Okay, so you could use, I'm sure there could be another way to prove that angle as 48. Alright, so we have 48 there. What else? Prove that ST is a tangent. Okay, I like this question. It's a converse question. Prove that ST is a tangent to the circle passing through M and S. M and S. Alright. Prove that ST is a tangent. This is what I'm going to do. Let's start by drawing a small circle that passes through MN and S. Alright. MN and S. Okay, let's try. Let me do something first. Let's give a few things. Alright, M and S. So mind this. Prove that what? ST. Where is ST? So basically, I've got this. Alright? ST is a tangent, so I want to prove that ST, T, and S. Do you notice I've got, so we look at the angles that we are given, the lines were given S, M, N. Alright? So let's extract N, M, S, because it says, so if you have something like this, extract this, and this is what? 48. Alright, now this is how I'm going to prove it. In your own separate working, you would say, if ST, now this you don't write in your answer booklet, but this is how you answer it. If ST is a tangent, then angle NST, see this angle here, should therefore be equal to angle M. Time chord. Angle NST should be equal to angle M1. And that should be equal to what? 48, 10. Now, this is what you are going to look for in the question. So they said, prove that ST is a tangent. You will then go and say, but if ST is a tangent, then this angle should be equal. So you go and look for these angles. Are these angles really equal? Let's go check. Yes, they are. 48 and 48. Lovely. So we will then say, angle NST. You see where I'm starting from? Starting from what I'm supposed to prove. M1 equals to 48. Converse. Okay, then you say, therefore, ST is a tangent. And the reason would be converse of tan chord. So the converse means you're actually working backwards. So the idea is, if ST is a tangent, then that should be equal. So we go look at these angles. If they are equal, then we say it is a tangent. Alright, that's how we work that out. Okay, good question. Good question so far. Is there any more? Looks nasty, but okay, let's try. O is the center of a larger circle, RTAP. RTAP, alright. OP is the diameter of a smaller circle. OP is the diameter, alright, so we've seen diameters there. NP is a tangent to both circles. NP, what is NP? Alright, lovely. And Rn is perpendicular, are we given? Rn, alright, we're given all the signs. P1 equals to X. Okay. Prove that PR bisects ORN and prove that. Okay. Alright, look, let's start by doing something here. The doctors in Cape Town, they've given us a diameter. PRT is a diameter. Automatically, see that it means this is 90 degrees. Okay, so I'm going to clean it so that we can just write it neatly. So this, and please be careful about the angles. You need to place the lines very well. 90 degrees. Alright, we're given OP as a diameter again. It means angle S also is what? These are the first things that we are looking at. Now, if you look at R and P, it's a chord that forms an angle X there, alright, with a tangent. And this chord here, okay, don't make a mistake. This chord here actually doesn't go into the smaller circle. This chord goes into the bigger circle there. Alright, so RP, because I know our eyes is actually coming here, but it's not true, because R is not in the small circle. So this angle is equal to what? Angle X. Alright, tan chord. I hope you'll be able to write the reasons. Here we're just looking at application, and therefore, because of a right angle triangle, that is 90 minus X. If you look at this small right angle triangle outside as well, that is 90 minus what? X angles in a right angle triangle. Alright. Okay, we're just working through first, based on what we can see. Okay, the examiner wants us to prove that PR bisects ORN. Let's see. PR bisect what? OR. Oh, we actually did. We are done. Because if it bisects, that means it cuts that whole angle into two equal. So 90 minus X and 90 minus X. Done. Done. If you missed it, please rewind quickly. Just pause and rewind so that you can get it. I don't want this video to be too long. And that's 5 marks there. So that worked. You see, it worked on our doctors in Cape. The doctors are doing a lot of wonders. The doctors are doing a lot of wonders. Alright. Proof that ROS is equal to PAT. ROS is equal to PAT. ROS and PAT. Okay, let's go check something. If we are looking at a cyclic chord, we're just going to walk through again. Look at this PRTS being a cyclic chord. Opposite angles of a cyclic chord are supplementary. So A would be what? 190 minus 90 minus X, which is 190 minus 90 plus X, which is 90 plus X. So this angle here is 90 plus X. Supplementary angles. Alright, supplementary angles. Okay, now what else can we deduce from here? Already we know the value of one of the angles. Let me just check again. We're looking for PAT. All right, PAT. All right, so our PAT is 90 minus 90 plus X. We are now aiming to get ROS. ROS. So we're looking at that angle there. ROS. Okay. ROS. Let's see. I know some of you have seen it and you're wishing that you can call me and tell me. Very soon we'll be having live classes where we can all Skype and discuss, and that would be lovely. That's one of the things that Krazifizix will be looking forward to get. All right, look at this. This angle is 90, angle on a straight line. And that gives me a right angle triangle, which makes this what? 90 minus X. And if that is so, angle on a straight line again. Alright? So this is going to be what? 180 minus 90 minus X. That is your O1 and O2, which is basically your ROS. And do you see it here? And automatically this gives us what? 90 plus what? X. And we are done. Perfect. I hope this video has in one way or the other been of assistance to you in your preparation. Oh, okay, we have this. Okay, let's try to check on this as well. And let's see. In the diagram, always the center of a circle. Alright. Prove the theorem, theorem 1. Okay, I'm just going to ask you to check on your theorems. Let's check this. We're just working through as many questions as possible. Determine the length of the radius of the circle. Just looking at all of this. AB equals to FD. AB, which is equal to what? FD. Okay, so AB is 8. And because this is perpendicular, it means this is 4. Alright, and 4. And FD equals to 8. The whole length here is 8. Alright, determine the length of the radius. And OF is X. Okay, look, basically, we're looking for the radius OB. And we know that we can use our Pythagoras theorem there. Alright, so we know that OB squared will be equal to what? FB squared plus OF squared. And that is what? 4 squared plus X squared. Alright. By the way, I do know that, okay, this is OB squared. Okay, but I do know that since I have this whole length as 8, then my OD, which is a radius, it is 8 minus X. And this radius here is actually equal to this radius here, 8 minus X, which is OB. So can I bring that in? 8 minus X all squared equals to what? 4 squared plus X squared. What do we have here if we expand? 64 minus 16x plus x squared equals to what? 16 plus x squared. Alright, so negative 16x. If I take this x squared over, then I have 16 minus what? 64. Alright, so 16x equals to, what is our 16 minus 64 quickly? 16 minus 64, 48. Alright, but minus 48, and then we divide by 16. Alright, and that should give us what? 3. X is 3. Done. Alright, so very simple and straightforward there. Okay, we just do this last one. We don't want the video to be too long, but basically we're applying all our principles. M is the center of the circle. SV, QR having equal chord SV and QR. RP and QP are tangents to the circle. Alright, we have that. RPQ is 70. Okay, let's see. Quickly again, start by writing doctors in Cape Town. You notice there's no diameter at all here. It's not even mentioned. We have an equal chord somewhere. Alright, but hold on. There's a radius here, there's a radius here, there's a radius here, there's a radius there. Okay? And these lines are equal. Alright, which automatically makes this angle to be equal to the, let me use a dot to make life easy sometimes, we just use dots. Alright, which makes this angle equal to that angle, a double dot. Alright, and you can use your color codes. But we are told that these, they are tangents. So can I quickly pick that? Alright, now, do you remember our tangents drawn from the same point are equal? It means this gives us an isosceles triangle. This angle must be equal to that angle. So basically it should be 55. But let's check. 180 minus 70 equals to 110 divided by 2 would give us 55. So that angle is 55. Angles opposite what? Equal sides. Remember, you need to write the reasons. Okay, but we're working through first. Now, can we check something here? We need to find the size of R2. Oh, we got that. 4 marks. Alright, first you have to just state that these are equal. And your reason would be tangents drawn from a common point. Okay. Alright. And then angles opposite equal sides, because these sides are equal. What's the next one? The size of Q1. The size of Q1. Oh, we forgot something, guys. When we were dealing with our chord, we forgot the tan rad. Again, falls under the, I did mention that there are 3, but I think I remember now I only talked about 2. Tan rad. Very, very key. Tan rad. Perpendicular to rad. Alright, 90 degrees. So I have a radius NQ, and this is 90. So automatically this becomes 90 minus 55. So Q1 therefore is 90 minus 55. So we're using what? A tan rad, tan perpendicular to radius, which makes this to be what? 35 degrees. Automatically this becomes 35. Remember, radius there. Alright, 35, which gives us this angle here. Alright, you have 35, 70, 180 minus, which gives us 110. We can actually then say that MQ, we can actually prove this. We've proven that it's a cyclic chord. Do you know why? Because 90 plus 90, this 10 rad, 180. Again, 110 plus 70 is 180, which gives us a tan chord. Alright, guys, I want to believe that we've been able, M2. Alright, determine the size of M2. Let's just get this one. And the next video will be on a bit of tricks. Okay? Determine the size of M2. By the way, look at this. Same segment, same chord and same segment. This line here is equal to that line. QR is equal to VS given. Therefore, they must obtain the same what? Angle. And that angle is what? 110. So you cannot get that angle without getting M1 first. Alright. And we are done. I hope this session, very informal, but I'm sure it has actually helped us to deal with our Euclidean. If there are any more questions, send to the group and we'll be able to deal with it, or send to our number. You see the number at the end of the video. Good luck.